Hey everyone, so before you can build any kind of solid, reliable database, you absolutely need a plan, a blueprint, right? Well, in the database world, we call that blueprint a data model. And today, we're going to break down exactly what that is and why it's pretty much the most critical first step you can take. Let's dive in. So here's the game plan. We're going to start with that core blueprint idea. Then we'll walk through the three main stages: the big picture vision, the detailed plan, and then the actual physical build-out. And to wrap it all up, we'll do a quick comparison so you can see how it all connects. Okay, let me ask you this. How would you build something complex, like a house, without a plan? I mean, really think about it. You've got plumbers, electricians, carpenters, all trying to work together with no shared design. It'd be pure chaos, right? You'd have rooms that don't connect, pipes sticking out of random walls, just a total mess. Exactly. You'd use a blueprint. It's that one single source of truth that keeps everyone on the same page. Well, guess what? Databases are no different. In fact, they're often super complex systems holding our most important data. So yeah, they absolutely need a solid, thought-out plan before anyone even thinks about writing a single line of code. And that plan? That's our data model. So what is it really? It's basically a collection of ideas that describe the structure of the data, the relationships between different bits of data, and any rules or limits the data has to follow. You can think of it as, literally, the architect's blueprint, but for your data. All right, so where do we start? We start way up high, at like a 30,000-foot view. This is our high-level vision, and we call it the conceptual data model. This is kind of like the first rough sketch an architect scribbles on a napkin to show you the basic idea of the house. The whole point of the conceptual model is to focus on the what, not the how. It's all about the big picture. We're just identifying the main things we need to keep track of. We call these entities and how they're all connected. And you'll notice there are zero technical details here. No code, no servers, nothing. It's purely about understanding the business requirements. Let's take a simple university system, for example. What are the main things we care about? Well, we've got students, courses, and teachers. Those are our entities, and the relationships, they're just the actions that connect them. A student enrolls in a course. A teacher teaches a course. See, simple. And we usually draw this out using something called an entity relationship diagram, or just an ER diagram. It's just a simple flowchart showing how all these pieces relate to each other. Okay, so once everyone agrees on that high-level sketch, it's time to add some detail. We're moving on to the structured plan, which is our logical data model. If the conceptual model was the rough sketch, this is the detailed floor plan. You know, the one that shows the exact rooms, their dimensions, where the doors and windows go. So how do we get from one to the other? It's actually a pretty direct translation. We take that conceptual ER diagram with its simple entities and relationships, and we start turning it into a structured schema. This is where we begin talking in database terms, things like tables, columns, and these special connectors called keys. This is where we start building the real database structure, at least on paper. So each of our entities, like student, becomes a table. The details about the student, like their name, become the columns in that table. Then we add something super important, a primary key, or PK. Think of this as a unique ID for every single student, so we never get two people mixed up. And to connect tables, we use something called a foreign key, or FK. This basically creates a link or a bridge from one table to another. But listen, this is still all on paper. We're not talking about actual servers or hard drives yet. And this is exactly what that looks like. Our student entity is now a student table. It's got a unique roll_no as its primary key. Same thing for the course table with its course_ID. So how do we handle that in roles in relationship? Well, we create a brand new table. Here it's called enrollment. And all it does is connect a student's roll_no to a course's course_ID using foreign keys. See how that works? That's how we build those relationships in a logical way. All right, we've got the floor plan. Now it's finally time to build this thing. We're moving to the most detailed level of all, the physical implementation, or the physical data model. In our house analogy, this is the contractor's master guide. It specifies the exact type of concrete for the foundation, the gauge of the wiring, everything. This model is all about how the data is physically going to be stored on a hard drive. We're getting into the real nitty-gritty here. We're defining specific data types. Is this piece of data text, a number,
A date? We're deciding on file structures and creating something called indexes, which are just a way to make looking up data super fast. This is the final concrete plan that the database administrator, or DBA, uses to actually build and run the whole system.
So there you have it. We've gone from a big picture idea all the way down to the nuts and bolts. Now let's put it all together and do a quick side-by-side comparison to make sure it all clicks. This table really nails it down. Up top, you've got conceptual, super high level, just focused on what data and relationships we need. Then you move to the logical model. That's our medium level of detail, where we define the structure with tables and keys. And finally, the physical model, super low level, getting into the nitty-gritty of how it's all stored. You can really see that clear path from a vague idea to a real tangible thing. Okay, for anyone studying for an exam, this slide is gold. You have to remember this. The flow is always conceptual, then logical, then physical. Don't mix them up. Remember ER diagrams? That's conceptual. Tables and keys? That's logical. Getting that distinction right is absolutely crucial. So you might be thinking, why bother with all these steps? Well, honestly, because the alternative is a nightmare. If you don't use data models, you end up with a messy, chaotic design. You get the same data repeated all over the place, relationships are a mystery, and that leads to tons of errors, horrible performance, and a system you can never, ever grow. A good modeling process, on the other hand, gives you a clean, organized, efficient database. It's really the difference between building a rickety shed and a solid skyscraper. So there you have it. You've seen the blueprints, from the first napkin sketch all the way to the contractor's final guide. Now the big question is, are you ready to learn how to draw them? But that, my friends, is a topic for another day. Thanks for joining me.